Hi everybody, today we are just going to discuss about OSPF. When you say about OSPF, it is a type of routing protocol. In routing protocol you have three major classes of routing protocol. We call them to be distance vector routing protocol, link state routing protocol and advanced distance vector routing protocol. Now when you say about OSPF falls under link state routing protocol, or otherwise you can call OSPF has the properties of link state routing protocol. So what is link state routing protocol? So now link state is much more scalable routing protocol. Now why do you call this to be much more scalable is, say if I have three routers in my network, say if B has to tell something to A would know about the network of B. Same as well as if I have some other routes over here, these routes as well B will be telling it to A. So then A will have a summary of all the routes present in routing B. That's why here it says that each router knows of the full picture of the topology. So link state routing protocol works with something called as LSA. LSA is called as link state advertisement. So now what does link state advertisement is? Say when a router comes up, when a router is configured with OSPF, say I would take the same example over here. Say B is configured with OSPF and the same A is configured with OSPF. So when B is configured with OSPF, B will send updates to A. So or B will say, hey, I'm B to A. So when the message reaches on the particular router A, that message will be called as LSA, link state advertisement. So that advertisement entry will have all the details of what you have in router B. So that's why it gives you an exact picture of the whole topology. Now, once if A receives that LSA, the LSA is collected by the router A and router A puts the LSA into a database. That database is called as link state database. So every routers which runs link state algorithms will have a database. That database is a collection of LSAs. So once he receives that particular LSA, he will flood to every other routers. So now that's why you call link state advertisement a flutter to every routers in that particular area. Just remember that OSPF will never send updates or LSAs beyond a particular area. OSPF will only send updates or LSAs within that particular area. Okay. Now link state protocols responds quickly to the topology change. So now this is called as triggered updates. The updates in link state, you call it to be triggered updates because say once a change happened in this particular, say the network over here B goes down. So when the network on this B goes down, so he will tell it to router A and router B very faster. So that's why you call it to be the updates are very faster. So and again more information and communication of LSA updates, link state requests and all those things happens between these two end routers. So as an overview of link state routing protocol, link state routing protocol is an open source, whereas it works with something called as LSA. LSAs are updated to every routers in that particular area. That LSA will be put inside something called as LSDB. So I hope you just got an overview of what is LSA, what is LSDB, what is link state routing protocol and all those things. Now you can see this particular diagram where A is sending LSA to B, the B receives that LSA, sends it to C, and all those things. So this transmission of LSAs happens between the routers. So now when you say about OSPF, OSPF is called as open shortest path first algorithm. OSPF is an open standard. It can run on multi-vendor products. Okay, so it was developed by IETF. IETF is a group from IANA. IETF is called as Internet Engineering Task Force. Okay, these are the guys who came up with the development of OSPF. Now when you say about OSPF, OSPF protocol works based on something called as hello packets, or they form neighborship with a packet called as hello packet. Okay, so this hello packet, say in our scenario, say B has to form neighborship with A and B has to form neighborship with B. If the neighborship should happen, I should be exchanging a packet called as hello packet. So the packet which is exchanged between them is called as a hello packet. So only with the help of exchange of hello packets you will be able to form neighborship between two routers. Now when you say about OSPF, as we said, it belongs to a class of link state routing protocol. So that is why it says propagates LSAs rather than routing table updates. So why they refer over here routing table updates is RIP was a routing protocol which was using routing table as an update to the next guy. But in OSPF, LSAs are used. So what is LSA? I said you earlier itself. So if B is coming up, B will tell to A that A, I'm come up, my network is so much, my router ID is 1.1.1.1. Say my networks are so much. So all the details it will tell it to the next router. So when it tells it to the next router, that is with the help of LSA, that is called as link state advertisement. Now when you say about link and state, link is always called as a router's interface. A router might have serial interface or fast Ethernet interface, any interface on a router that represents where you have configured OSPF states about the link. State describes, say, how are you forming neighborship, say whether if you are forming through serial or forming through path. So link and say says the interface and the way how they have formed neighborship with the routers. So next point is floods LSA. As I said you earlier itself, say once if B receives an LSA, once say B receives an LSA, B will send it to A will receive it, put it inside his database, and he will flood it to B. So once a router receives an LSA, he will flood it to every other routers, every other possible routers inside that particular area. So that is called as link state database. LSAs are flooded. So can you see the next point says pieces of all together LSAs are put into something called as LSDB. Now one more thing is on LSDB or on the link state, you will run a algorithm called as shortest path first algorithm, or in short you call it to be SPF algorithm, or otherwise it is called as Dijkstra algorithm. So based on this particular algorithm, the shortest path to a destination is calculated and that shortest path is put onto the routing table. So now when you say about OSPF, OSPF has three types of tables. So the very first you call it to be neighbor table. The second one you call it to be a database table. The third one you call it to be a routing table. So now what are the entries inside the neighbor table is only directly connected entries you will have it on your neighbor table. But when you say about database table, it will have all the pieces of LSA put inside the LSDB. So on top of this LSDB, when you run SPF algorithm or Dijkstra algorithm, the least cost path will be selected as the best path, and those paths will be entered into a table. That table is called as routing table. So I hope the basics are clear here now. Okay. Now next is, say we said when two OSPF routers are forming neighborship, they exchange a hello packet. So inside a hello packet, you have certain criteria for them to form neighborship. Only if those criteria are met, they would form neighborship, otherwise they will never form neighborship. So now when OSPF adjacencies are formed, see, OSPF sends the output as multicast. So here it uses an address called as 224.0.0.5 as the multicast address to send the updates to the next router. So inside an hello packet, if you see that there are criteria called as router ID, hello and dead interval, neighbors, area ID, router priority, DR IP address, BDR IP address, and authentication. These are some of the scenarios, or these are some of the criteria which have to match if they have forming a neighborship. So now when you say about a router ID, so what is a router ID? So before that, I'll just configure OSPF. So I'll just take here two routers as such. Say I'll take, say, router 1 and say router 5. So here I do have router 5. Router 5 is connected to router 1. So I do have router 1 as well. So R1. So the IP address on R1 is, if you check, it's on the Ethernet interface, is on the pass Ethernet interface. So on this interface, you can see an IP address, say 155.1.125.1 on R1 router. Now when you see it on R2 route, R5 router, you can see the update as so. Now if you see here, it is 125.5. on R1 router is 1. So let me ping from this router to the other router. We'll say 155.1.125.1. So yeah, possibly I'm able to ping from this end to the other end. So now if I check my routing table, no routing protocols are present, but I do have a default entry. That's a default routing table is there. So now if I configure OSPF, I'll have to just go to the configure terminal. I will have to say router OSPF, and here you have something called as a process ID. Process ID value ranges from 1 to 65535. You can have any particular value. So one value would represent a database. So here for example, I am just giving a value called as 100. Then on R5 I am specifying which network am I going to advertise it, because R1 and R2 are familiar with 155.1.125.0 network. So I'll just say advertise network 155.1.125.5. I would give a wildcard bits which would exactly match it. And in OSPF design, this is very much important that here you have something called as a concept called as area. So what is areas is, say when you say about an autonomous system, inside an autonomous system you will have huge number of routers, because OSPF doesn't have any limitations like RIP. RIP has a limitation like 15 hops. Beyond that it is not possible. OSPF doesn't have anything much specific like that. So here you, in an autonomous system, you can have n number of routers. So just to summarize the routing table entries, they have come up with something called as areas. So areas, you can have multiple areas. Only area 0 should be the core area, or area 0 is called as a transit area, or otherwise you call it to be a backbone area. So now I am just going to configure it as area 0 itself. So here we are back. We'll just configure here 155.1.15.0.0.0.255. Here we are going to say it as area 0, area space 0. So that's it. I've configured over here. We'll say here debug IP OSPF. So now let me configure the next router. So can you see here we saw that hello packets are sent by the help of 224.0.0.5. Can you see that? So that packet is there. So now let me configure the second router, which is R5 router. If I check show IP interface brief, here you could find the network to be 155.1.15.5. so here also I will have to configure OSPF. We'll say configure terminal router OSPF. Either you can define the same router ID or you can go for a different router ID, anything as you wish. I am using the same router ID over here. We'll say here network say here network 155.1.15.0.0.0.255, and I have to specify which area it belongs to, so we'll say it as area 0. So before me telling this, I just want you to show the stuffs on this, so better I'll just say here debug IP OSPF events and debug IP OSPF adjacency, so that I can just show you something. Okay, so now let me configure the same stuff. Router OSPF 100. We'll say here network 155 or 1.15.0.0.0.255 with area to be 0. So now once I enter this, you can see that two OSPF routers forming. See that. This is how two OSPF routers form neighbors, and see the process that happens between them. Yeah, that's very good. Okay. So now I'll come to this. I'll explain you what is this. Before that, okay, so now here we said that there are 3 type of tables. I'll just show you that. Show IP OSPF neighbor is a command. Show IP OSPF neighbor is a command to check the neighbor table. So can you see here? Can you see the neighbor ID? That is R1 router's router ID. So can you see that 1.1.1.1 is a router ID for R1. So I'll explain you what is router ID. So that is the neighbor R1 router's router ID or my neighbor router ID, and the priority is nothing but the priority of the interface. The priority is used in a DR BDR election, and it says the neighborship. The neighborship over here is full, and the dead timer is 31 seconds showing over here, but dead timer here in OSPF is 40 seconds. So the timers for OSPF are hello timer and dead timer. Those are the 2 timers with OSPF. Hello you call it to be 10 seconds and dead you call it to be 40 seconds. In the sense, every 10 seconds I would be sending hello packet. So can you see here, if you see at the top, can you see received hello from 1.1.1.1. Can you see the timing to be 35 seconds over here. If you see the next message, can you see at 45 I'm again receiving. So every 10 seconds I will be sending, as well as I would be receiving hello packets. So with the help of hello packets is what I do from neighborship. So now the next type of table is called a show or database table. So the command to check the show IP OSPF database table. So if I would check the database table over here, I would come to know about the LSAs. So if I see here, you have a router link LSA. It says 1.1.1.1 is a router. This router is the one who is advertising it. the age of LSA. The age of LSA is almost 30 minutes or 1800 seconds. So then you have a sequence number, checksum value and all those things. So next, if I check the routing table, show IP route, you will come to see about the routing table, but here you are not seeing about any OSPF entries. So if you have to see some OSPF entries, in the sense what should I do over here is, on R1 router, if I check my routing table, if I check show IP route, say I could see 155.1.0.0 as well as 1.0.0.0 in my routing table. So I will have to advertise both of them. If I do advertise both of them, then they would form neighborship. Then one dot will come to the other side. So I would say here router, say OSPF 100, we'll say the network to be 1.1.1.0.0.0.255 with area to be 0. So once this is advertised, if I would come to the R5 router, and if I would check the routing table, show IP route over here, I will be able to see the route O. Can you see? So once I see here O, can you see it says 1.1.1.0/32 network. So that is learned through O. O over here says it is OSPF, and 110 says it's called as a administrative distance value. So the AD value starts from 0, goes up to 255. 0 says the trusted value. So 255 is the least trusted value. When you say about static, it's when it is directly connected, it has the highest preference. So that will be called as 0. Static will have a value 1, and OSPF is having a value called as 110. So these are the values by which AD is identified. It just simply says the trustworthiness of a routing protocol, how a router believes on it. Okay. So now you saw this routing table. So in the routing table you will be seeing about OSPF routes. Okay. So next we were exactly talking about router ID. So when you say about a router ID, what is a router ID? Is say a name by which a router is known to that OSPF area, or inside that particular area is called as OSPF routes, you call it to be normally. So here OSPF router ID you call it to be. If I check show IP protocol, so now protocol, yes, IP protocols, can you see OSPF is configured, and can you see the router ID? It's 5.5.5.5. So now whenever you configure OSPF on a particular area or on a particular router, see the highest physical interface will be selected as the router ID for that particular area. The highest physical IP address, say one router, if it has say 10.1.1.1 on one interface and 20.1.1.1 on another interface, the highest IP address will be elected as the router ID. That is the very first criteria scenario. On the second scenario, say I do have a physical interface and I do have a loopback interface. I do have a physical interface as well as I do have a loopback interface. So once I have a physical and a loopback interface, the preference is given to loopback interface. So that is why loopback will be preferred as the router ID. So now if I check show IP interface brief over here, I do have two IP addresses on the interface. You can see here 155.1.15.5, 155.1.5.5. so many IP addresses. Only 15.5 is up because the interface is up and now the others are administratively down. I have put all the interfaces in the shutdown state. So only 155.1.15.5 as well as 5.5.5.5 are the interfaces which are up. So out of these two, the IP address on fast Ethernet 0/0, which is 155.1.15.5 is the highest, but still it has selected the router ID has 5.5.5.5. Why has it selected? Because loopback. So loopback is given preference when you have two interfaces, which is physical as well as loopback. The third method of configuring a router ID is you can directly go to the command prompt. You can say under router OSPF 100. You can say here the router ID as, say, I would say here 55.55.55.55. So I'm just saying a router ID, but this command will never get executed until you restart it. So now if I would check here, show IP protocol, if I check show IP protocol, still you can see the interface. I saw the router ID is 5.5.5.5. So if I would type a command clear IP OSPF process, if I would restart the process, this would happen. Here I have to say yes. So now after the process gets restarted, can you see the neighborship between two OSPF routers has gone down. So now if I check show IP protocol, can you see the IP router ID selected as 55.55.55.55. So in simple, what is the router ID is? ID by which a router is known in a particular, or a number by which a router is known to other routers is called as router ID. Next, the next criteria is hello and dead interval. Now when you say about hello and dead interval, I said you OSPF has these timers hello and dead. Hello is 10 seconds, so every 10 seconds I would be sending hello packets to common neighbors. Dead timer is 40 seconds. Now what does this dead timer tells about? See, dead is 40 seconds, so every 10 seconds I would be sending hello packet. So now if I am not receiving an hello packet for 40 seconds, my neighborship will go down. So now if you check on this router, show IP OSPF neighbor, show IP OSPF neighbor, can you see the dead timer is 31 seconds, and again every 10 seconds you're getting an update. Can you see this keeps on increasing after, because every 10 seconds I will be getting an update. Now I'll do one thing over here is I'll go to R1's interface. I'm just going to shut down the interface over there. I'm just going to say interface fast ethernet 0/0. So I would say here shut down, and let me come to R5 router back. So once I'm back to R5 router, if I check show IP OSPF neighbor, so can you see the timer is going down? Can you see this timer is going down because I'm not getting hello packet from the neighbor. So if I'm not getting a hello packet within 40 seconds, so my neighborship will go down. That will go in a reverse order. Can you see it's going 9? So then almost it reaches 0, the neighborship will go down. So can you see the neighborship has gone down? Now if I check show IP OSPF neighbor, no neighborship is there. So instead, if I would go to the first router and if I would bring it back, I'll say interface if I would say here no shutdown. Next, if I would come and check it on R5 router, show IP OSPF neighbor, checking here show IP OSPF neighbor. Yeah, can you see the neighborship has come up? Okay, so if you want to check these in detail, you can just check to interface, show interface. Let's show IP OSPF interface fast Ethernet 0/0. So on this interface, they would have given you here saying that, can you see the hello timer is 10 seconds, and can you see the dead timer is 40 seconds. This would have been specified on each interface. Can you see the next due is in 5 seconds. In 5 seconds, another 5 seconds, I have to get an update from the neighbor. Next is neighbors. So if two OSPF routers has to form neighbors, they should be directly connected. Only if directly connected routers, they will be able to form neighborship. That is why neighbors. Now area ID. If these two routers are forming neighbors, they should be of the same area. Different area routers will never be able to form neighborship. Next is router priority. So now what is router priority is, say in a broadcast domain, I might have multiple switches inside the multiple routers connected to a single switch in the broadcast domain. Say for example, so here I have B, A and B. So when I have these three routers, when I have these three stuffs, say in this is called as a broadcast domain. So in this broadcast domain, what will happen is, if B is trying to tell something to A, B will send a message that will A will receive it, and as well as D will, because it's a broadcast. So once A receives it, he will send it to D. Once D receives it, it will send it to A. So it's almost like a mesh kind of topology, because everyone will tell to everyone in this particular network. So now in this particular network, to manage a particular network, I need a head in this particular domain. In symbol, I need a master router in this particular domain just to manage the routers in this particular area. So that particular router is called as DR, designated router. In the sense, he is the head. So how is a designated router elected is, the very first thing is a router priority. So now if I would check here, show IP OSPF neighbor, it will tell my neighbor router's priority. Can you see it is 1? So that is by default. If you see on this particular interface, the priority 1. So every interfaces by default has a priority 1. So now say for example 5 routers are connected to a switch in a single network. So everybody will have a priority 1. So when everybody has a priority 1, who will be the DR? So DR is nothing but the higher priority. So if you want to increase the priority, you can go to a interface fast Ethernet 0/0. You can say here IP OSPF priority, and you can put whatever value you want. If I say 5 over here, I can come out and check show IP OSPF interface fast Ethernet 0/0. So once I check over here, can you see the priority has changed to 5? So this is how I can change the priority. Priority is to maintain a DR, DDR in a particular broadcast domain. So the highest priority will always be the DR. Next, BDR is called as a backup designated router. Say if R5 is the DR, he will be managing all the other routers in this particular domain. So if R5 is linked to the switch goes down, the connectivity from R5 to every other routers in the network gets lost. So then you have something called as backup designated router, or BDR. In a sense, if the router goes down, if the DR goes down, BDR takes up the position and comes up as the next DR. Okay, so that is what the DRIP and BDRIP. Now why do they call DRIP and BDRIP is, See, when priority is everyone is having the same priority, then how will you select a DR? So when two OSPF routers are coming up, the highest IP address, whoever has the highest router ID will become the DR. That's why DR IP address. DR is elected based on the router ID. So whoever comes up first, the among say if two routers are coming up 1.1.1.1 and 5.5.5.5. So when two are coming up, 5.5.5 is the highest. So 5.5.5 will be the DR in that particular domain. Okay. Then the last point is authentication. So in OSPF it supports three types of authentication. One is called as authentication 0, is called as no authentication. By default, when we configured OSPF, we didn't configure authentication on it. So two OSPF routers, when they were configured with OSPF, they came up because no authentication. That is called as the very first type of authentication is authentication 0. The second type of authentication is called as plain text authentication. In the sense, passwords will be there, password will be exchanged on both the sides in a plain text format. That is called as authentication 1. The third type of authentication is called as authentication 2. That is called as MD5 authentication, message digest file. It's an hashing algorithm. So with every packet, a hashed value of the password will be attached to the packet. So when it goes to the other side, they form neighborship only if they matches. So when you see inside this hello packet, see hello and dead in trouble, you can see a star. Router ID, area ID, you can see a star. Authentication. So now if these criteria matches, only then they will form neighbors. Otherwise they will never form neighborship. Okay. So I hope we have understood what is OSPF, what is link state routing protocol, what is open shortest path first, what is an hello packet. So that's up. I'm just ending a short of OSPF over here. Next you will be updated in the later.